find the radius and the interval of convergence of the following power series. So we got sum n from 1 through infinity of n square xn over 2n. So we can rewrite this as writing x separately, like x to the n, and the coefficient is just simply n square over 2n, and n goes from 1 through infinity. Okay, this is 2 raised to n. So comparing this with x minus 0 to the n, x minus a to the n, a is center, so x minus 0. So for this question, so we can say the center a is 0. So later when we are writing interval, it will be, here is the center a, and we go to the radius somewhere a plus r and a minus r. So this is 0, so it will be, I don't know, maybe negative 3 3, negative 2 2, negative 5 5, negative 1/2 type. Okay, anyways, so to find the radius, we consider everything as an. That's the general notation. And now we use the ratio test, and we know that we find the ratio test. From the ratio test, the series converges if the limit is less than 1. So the ratio test. Okay, so for that one, we're going to write limit n approaches to infinity of absolute value of an plus 1 over an. That is, in this case, an is the whole thing. An plus 1 is replace n by n plus 1. It's not simply plus 1. N by n plus 1. Okay, so n square becomes n plus 1 square over 2 raised to n becomes 2 raised to n plus 1. Okay, this is not like 2 raised to n plus 1. Okay, that's not true. Just replace n by n plus 1. And x, that's on the top, x n plus 1. So that's a n plus 1. N plus n plus first term divided by an is the whole thing now. N square xn over 2 raised to n. Now we need to take this limit, and remember, when we have 2 raised to n plus 1, we can factor as 2 raised to n times 2 raised to 1, or that's simply 2. So this one is then limit n going to infinity of, and xn plus 1 in the same way, xn plus 1 is x raised to n times x raised to 1, or just x raised to 1 is just x. So we can cancel. So let me rewrite one more time. N plus 1 is squared. Xn plus 1 is x raised to n times x over 2 raised to n plus 1 is 2 raised to n times 2. This division into multiplication, flip this fraction. So 2 raised to n on the top, n is square x raised to n on the bottom, and we still have the absolute value. So let's cancel a couple of things. xn cancel, 2 raised to n cancel. Now we are ready to take the limit. Okay, this one is then limit n approaches to infinity of, so this absolute value is now valid for only for x, because n plus 1 square is positive, 2 positive, n square positive. So I can just leave absolute value for x. N plus 1 is square on the top, and on the bottom is 2n squared. Okay, so this x is independent of n, so we don't have to worry about that part. Now let's find this limit, and this times x would be the total limit. So this one is, if we expand the top, it's gonna be n squared plus 2n plus 1 plus 1, but we only need the leading terms, because when n goes to infinity, so this is n squared on the bottom, 2n squared, so this will be 1/2. So this limit is in fact 1/2. So 1/2 x. Okay, so the whole thing is 1/2 absolute x. And we know that when this limit is less than 1, the series converges. So for convergence, we need to take this limit less than 1. Now let's isolate x by moving 1/2 to the other side. So 1/2 times, so we multiply both sides by 2, so that will be x less than 2. So this is the radius of convergence. So 2 is the radius of convergence, and if we look at the interval now, 0 was the center, 2 is the radius, means time go towards 2, so 2 and then -2. But what we know now is this series, the power series, the given power series converges inside -2 to 2, diverges outside of this one, but we don't know what happens, converges here, okay? We don't know what happens at -2 and at 1. So we need to test those points at -2 and at 2. So let's write down the original series, that's n square xn over 2n. So when we replace x equals -2, so that would be n square xn means -2 to the n over n square. Okay, my bad, what is that? 2n. Okay, that's the 2 raised to n, not n square. So this will be 2 raised to n goes from 1 through infinity. Now -2 to the n is same as -1 raised to n times 2 raised to n. So let's simplify this. N from 1 through infinity, n is squared, -1 to the n, okay, times 2 raised to n and 2n. We can cancel from the top and bottom, so I'm left with just that. So let me rewrite here, and from 1 through infinity, let me write 1 raised to n in the front, n is squared. Okay, so I'm going to consider this in a moment. So we need to conclude if this series converges or diverges. Okay, if you look at closely, I mean there is no bottom. When n is very big, n square means infinity. So these terms are not going to 0. Then from the test for divergence, since these are not gonna approach to 0, this series diverges. So we can simply call this one diverges by the test for divergence, because these are not marching towards 0 eventually. That means divergence for sure. Even if they march towards 0, that does not mean convergence, but then we have to do some other work. So that is not, -2 is not included. In the same way, let's do at 2. The series is n squared xn over 2n. So x means 2 now. 2n over 2n, 2 raised to n, n from 1 through infinity, 2n cancel. So this is simply n squared. Okay, n squared not going to go to 0 when n goes to infinity. So this one also diverges by the same thing, the same test, the test for divergence. That means the endpoints, I mean we were testing -2 and 2, these endpoints are not included. So the final answer is, what is the radius of convergence? So the radius of convergence is 2, and interval of convergence is -2 to 2. Not inclusive means we use parentheses. If one of them is included, we have to use bracket for that side. So this final.